Hello and welcome to OWASP and CSA IoT, Impacting Medical Security. My name is Aaron Guzman. I am the Product Security Lead at Cisco Meraki, in charge of all things hardware, firmware, and IoT security. I also lead the OWASP IoT project along with sub-projects, co-chair for the Cloud Security Alliance IoT Working Group. I've co-authored the IoT Penetration Testing Cookbook. I'm a technical reviewer with Packet Publishing and No Starch Press. Practical IoT Hacking is the latest publication released in March of this year, 2021, although right on its heels is Bug Bounty Bootcamp, which is soon to be released in the coming months. In Practical IoT Hacking, you will find some medical device oriented attack techniques for network protocols such as DICOM. So make sure to check them out. I will promise you, you will learn a thing or two. So really happy to be here, presenting on, OWASP and Cloud Security Alliance. I will first, talk about some of the hats that I wear, right? Multiple depending on the day. And we'll get started with OWASP for those who don't know. For those who are familiar, you may have come across OWASP if you are trying to remediate a software security vulnerability. But for those who do not know, OWASP is an acronym for Open Web Application Security Project. OWASP is a nonprofit started up in 2001, and it's actually the 20th anniversary this year, so it's a big milestone. OWASP has great, very smart experts from all paths around the world. There are regional and global events. And what I mean by events is conferences and hackathons. So there's global AppSec USAs, Europe, APAC, Latin America, but also regional and states, chapters, right? Like AppSec California is one that is near and dear to my heart and one that I help organize, pre-pandemic at this point. But essentially, OWASP is an authoritative source for software security. So if you get a chance, check out the OWASP flagship projects. Won't be a waste of time. You might be surprised and find a thing or two that you didn't know before, whether it's a piece of knowledge or a tool or guidance. So I'm here to talk about the OWASP IoT project, Internet of Things. This project was founded in 2014 and designed to help manufacturers, developers, and consumers better understand IoT security issues. And now the idea was to kind of cast the net wide and apply our knowledge and education, to as many paths and areas and audiences. So that's the way we've kind of approached some of our projects with projects or tools and guidance and best practices. And when you think about medical device security, right? Medical device security, the platforms that they run on, it could be embedded Linux, it could be Windows, it could be bare metal, meaning, microcontrollers without operating systems. And software is controlling, right? Is the crux of controlling the functionality of those devices. And what the IoT project is some of the projects that we work on is, to help the security and the awareness aspects of developing and deploying, right, and building. So we've been cited in numerous publications and information security standards. The most recent one that I've stumbled upon was the FTC had cited us for building security into Internet of Things in 2021. To our surprise, which is awesome. We collaborate with alike organizations, whether that's ANISA, Cloud Security Alliance, other companies, around the world. We're looking to collaborate more, GSMA, other folks in the space, especially in the medical, right? We'll talk about, some of the work in the medical space, obviously. So the project, we've broken it up into a couple of different categories, namely seek and understand, that we'll talk about today. And we'll also talk about the validation. And so seek and understand, we have a couple projects that we'll talk through today. The top 10, the IoT top 10, and IoT Goat. And to make the IoT top 10 kind of more applicable for some groups, so we created a mapping project and mapped them to a number of sister projects in the industry. IoT top 10, this is essentially our flagship project. It's meant to create the awareness, and supposed to be top 10 things to avoid when building, deploying, and managing IoT systems. And when we develop this list, we have a methodology to which we use, and we gather data from different sources, right? And we look at sister projects. And the theme was simplicity. Again, casting that net wide to manufacturers, consumers, and the enterprise as well, who are using these devices in their network. And we wanted to highlight essentially what are the highest priority issues you should be aware of. Now, the list isn't necessarily ranked from the most critical to the least critical, although from the prevalence, you'll notice, ranging from one, how common and pervasive some of these issues are, and the impact that attackers can gain and once exploited into an environment. And when talking about medical, that gain could be someone's life, right? IoT Goat. What is IoT Goat? IoT Goat is a deliberately vulnerable firmware. And what we did is we based it off of OpenWRT, and OpenWRT is an build system. And what build system is, it makes it easier essentially to compile and build firmware. And it does that in a way, right, that's open source, and which is why we chose OpenWRT. The other reason why we chose OpenWRT is its compatibility with old devices that you may have, let's say laying around old routers or old networking equipment, or devices that are compatible with OpenWRT, and give you that flexibility to flash IoT Goat and to practice finding and identifying and exploiting vulnerabilities within firmware. So when we developed IoT Goat, we incorporated as much as we could of the IoT top 10. And when I say as much as we could, I mean everything aside from the hardware and kind of process base. Well, actually everything aside from the hardware, and that's actually in our roadmap as well. And so what we wanted to do is use this vulnerable firmware as a learning platform for professionals, researchers, software developers, anyone who is looking to get into firmware hacking, IoT hacking, and give them that playground to let loose and to practice and to level up and gain that confidence. If you've ever gotten started into IoT hacking, firmware hacking, it's a tall order, right? If you have no previous exposure or visibility. And so again, this is meant as a platform to help enable folks, get more confident and familiar with the types of vulnerabilities that are within firmware. So I'll show a few screenshots. Here's the login page. By the way, this is IoT Goat is up on GitHub. If you want to have a play, you're more than welcome to. Here is the secret developer diagnostics page. You'll find these somewhat common or uncommon, maybe left over from debug code from devices. Usually, right, it is not a good sign when you find these types of diagnostic pages that allow access, by other means, that elevated access. So we've developed challenges to walk you through how to find the vulnerabilities. And a part of our roadmap is how to fix the vulnerabilities as well. And what you see here on your screen is the backdoor for IoT Goat, essentially a service that is running on startup. And you can connect to that particular service and get root access and practice post-exploitation if you'd like, meaning going from device to device inside of a network, or keeping it simple. Simple is always the best, right? Especially when you're getting started. This screenshot here is the listening network services from Nmap. And you'll see, the common HTTP, UPnP, as well as a couple of services that run on high ports that are unknown, which might be fruitful if you poke at them and you find out what they're running. Who knows? You may get access to a device. You may exploit a vulnerability. So good luck. Have a play. Again, IoT Goat is there as a resource for you all. And we'll talk a little bit more of what you can use in conjunction with IoT Goat next. So our other category is validate and test. Talked about seek and understand, and this is validate and test. And in validate and test, we have the IoT security verification standard, firmware security testing methodology, and byte sweep, which is a tool, a firmware analysis tool. Firmware security testing methodology was meant to lower the barrier of entry for IoT hacking, including medical devices, right? So this could be used hand in hand with IoT Goat. And the idea is to enable more professionals or more folks who are interested in getting into firmware hacking and providing those guide rails and providing the guidance and kind of a systematic, in a systematic way, all in, one resource. And if you're like me, when you get started in firmware, you'll be like, there's so much going on. I don't know where to start. This might be for you. And like any other methodology, right, you can jump from step to step. And what we've done is we broke it down into 9 steps, right? And the 9 steps, again, depending on your scope and your expertise and the foothold you may already have, you can jump around as mentioned. We've went ahead and provided tool usage examples, walkthroughs, right? Again, to be able to help and show and teach essentially, the common techniques, the common tools. And what we've done is create a companion virtual machine with preloaded tools, vulnerable firmware such as, IoT Go, but also a few others that the industry has provided, and even some that have known vulnerabilities for products and manufacturers out there, zipped up and, trying to keep the space minimal. So again, really trying to enable more folks to get going and get some help with firmware hacking and start poking around into, IoT devices, medical devices, right? IoT Security Verification Standard, ISVS. So ISVS, what it consists of is 3 verification levels. And we have 5 chapters, or if you want to call them domains, with a total of 138 controls. Now, don't pay attention to the controls so much, but the aim of the project is to create a basis for testing IoT applications, software, and their technical controls, but also to develop contextual requirements for secure development and design. So you can use it as part of the hardware design for medical devices. You can use it as a set of product security requirements to be included into product requirement documents, PRDs, if you're a manufacturer. If you're buying devices, you can use them for procurement of medical devices, developing medical device security training, assess the security posture of a medical device, and provides a basis, right, to define verification levels based off of the medical device's risk. Today there isn't, a standard to help normalize, the coverage of how well my IoT device, my medical device has been tested. It's essentially, tribal knowledge, or maybe there's an overview of a methodology, but this aims to plug those gaps and help clear the ambiguity there. And so we followed our sister projects within OWASP. The ASVS is for the web, the MASVS for mobile, and the SCVS for software composition. Think about it like supply chain and building software. So this project is still, is in release candidate stage. It's been a rough year, but we are hoping to get it out fairly soon for you all, and we're just tidying things up. So we are open to additional feedback and contributors, and we'll get to how you can reach us later on. Some honorable mentions that affect the medical device security. The embedded application security best practices were previously released around 2016 timeframe, and we are doing a refresh with newer techniques, newer guidance, different formatting. Right now we have a base set of 7 that you see on the screen here, with sensitive data management down to cryptography. Initially we had 10, and again, this is still a work in progress, right? And if you notice Yocto and OpenWRT, these are very popular embedded build systems for devices. So likely, your medical device that you purchase, if it has a Linux operating system, is built with one of these build systems here. And the hardware security testing methodology is something that is a work in progress. And again, kind of taking that step even lower from firmware, or actually stage lower, right? Where you have the hardware and let's say you need to pull the firmware and to find vulnerabilities and then exploit them. This hardware methodology, testing methodology, will help you in that endeavor when you're embarking on those types of assessments, those hardware analysis, the tools you'll need to have in your toolkit, the techniques you'll have to keep in mind, when to try which technique. And again, it's for those folks who, again, need that guide rail, a little bit of a kickstart, or something to, kind of keep you honest and reference as like, hey, I am ensuring I'm covering these certain areas for these vulnerable hardware debug interfaces, these UARTs, these serial interfaces, these JTAGs. How do I connect to these? What do I do afterwards? How do I gain root access and gain persistence? So we hope that, these resources will be helpful to you all. But you might be asking, this is OWASP. These are OWASP projects. Why is OWASP involved in IoT and in hardware and in embedded? Well, at the end of the day, everything is software, right? Without software, hardware would not be able to function. Firmware would not be able to talk to the hardware, the drivers, right? Wireless protocols, all software. Zeros and ones, right? If you want to take it down even to its lowest. Switching hats now to my Cloud Security Alliance hat. A brief intro about Cloud Security Alliance. It's a global organization with a similar structure than OWASP. Free to join and participate. Resources, best practices, and events as well. I guess the larger differentiator would be the cloud security certifications that they offer. And OWASP does not offer such certifications. They are 501(c). Both great groups. I give 100% of credit to both of these organizations and where I'm at. Without either of these organizations, I would have not had opportunities to edit books and write a book. So keep that in mind as you're pondering whether I should get involved throughout this presentation. So the Cloud Security Alliance IoT Working Group. I've been a part of this group since the beginning, and it was originally part of the mobile working group in 2014 when we spun off. We've also, worked with industry, regulatory, and corporates as well. From the collaboration perspective, and we've been lucky enough to be cited in RFCs and different standards as well. And you can see a couple of screenshots there with one of our RFCs, RFC 8576. We've put out a number of different publications throughout the years, specific to industries, specific to the enterprise, right? Two medical publications have been released, and we're working on a third, which we'll talk about today. So I guess with the collaboration in mind, OWASP and Cloud Security Alliance work together to release the secure medical device deployment standard. If you may be wondering, so there's a lot of cross-pollination. Again, we're all saying the same thing, and we should all be working together. So if you all are in similar groups and you want to collaborate, let's do it. Now, the IoT Controls Matrix. This is the flagship project for our IoT Working Group. It is modeled after the Cloud Control Matrix, the CCM. There's 165 controls aimed at enterprise IoT that incorporate multiple layers of connected devices, cloud services, and networking technologies. So we have 21 domains, security domains, and that's ranging from asset management, like you have to know what you have to get started, from governance, even legal, down to vulnerability management and security testing activities, whether that is web application security testing, firmware, bug bounties even included. So it's really holistic. So it should be a helpful resource for healthcare delivery organizations and any organization deploying connected devices in their networks. So how we're evolving the IoT Controls Matrix is we want to glue the process, policy, infrastructure, ecosystem controls with the device itself. And, a part of that is, the industry is changing. We have, zero trust, zero touch provisioning, supply chain issues are, I don't want to say at its height, but it is up there and it is on top of everyone's minds, especially in 2021 and the day in remote working now. Right, and people are sending these appliances in their networks and these IoT devices, and they're just connecting to corporate environments, and managing and the whole complexities that come with that. And so for the next version, we're looking to not only evolve and refine our controls, but introduce a shared responsibility matrix tailored towards IoT. And again, to kind of expand that applicability, we create mappings to either sister projects, such as ANISA's IoT baseline, security baseline, and the various NIST standards out there, and of course, Cloud Security Alliance projects like CCM. As you may have noticed, securing IoT is not an easy task, right? Medical device manufacturers must trust their supply chain partners, and the supply chain partners must do their due diligence, and that cascades down, right? Even further to the enterprise and consumers, which they must trust the connected products, that they meet, minimum standards and controls. And typically this trust is obtained through, a series of questionnaires and back and forth, the interaction with each group or each party, or a sort of trust portal that satisfies procurement requirements. So when you're purchasing things, but at the end of the day, right, given the complexity of IoT and the scope, right, there is not one size fits all. Solutions and controls must be interoperable, must provide automation to scale, and they have to be validated, right? There has to be, internal and external validation to ensure these controls are working and that the lights flicker, the alarms are going off when they should be. So an ongoing project is Zero Trust for IoT. And this is really important for those medical devices that you may be plugging in and, hey, now all of a sudden they are paired and they are working. They are onboarded with, again, zero trust or touch, I guess you can say. And, there's a methodology to the architecture in which, we'll break it down from the onboarding, the authentication, the authorization, and then how you monitor those types of devices and the different policies you want to employ. And then, if there is a root of trust, hardware root of trust, how do you leverage those for that kind of secure identity? Otherwise, if the identity could be tampered with, so could that trust, right? The Cloud Security Alliance Medical Device Incident Response Playbook. The goal of this project is to establish the best containment, eradication, and recovery practices for each category while minimizing the risk those practices have on patient care. So we've modeled this playbook after, the NIST SP 800-61R2. But we created our own kind of differentiators here in the sense of, we're defining incidents in this context as a vulnerability disclosure and one or more CVEs affecting medical devices within a healthcare delivery organization inventory, or the discovery of malware, ransomware, or loss of availability of a medical device. So this might sound all too common. You may have heard all the vulnerabilities reported for medical devices in the past. Or what about the novel WannaCry a few years back, 3-4 years back now, which took down a number of hospitals and was devastating for some and cost lives. So this playbook is supposed to be used as a basis, as a starting point to incorporate into an HDO, a healthcare delivery organization's program. And so we've defined these 7 clinical scenarios. And these clinical scenarios range on based on the types of devices that are being used. So, for example, number 1 would be, if it's safe to connect from the patient and the network. Is it safe to connect from? Is it safe to disconnect from the network? Can the devices be shut down safely and removed from the patient? Is a disconnection possible, but with clinical impact? So we'll go through a couple of these, or I'll just show you the workflow that example workflows. Again, these will be contextualized or should be contextualized to internal processes. But what is always step 1 with an incident response, right? You can see the list here, right? The 5 phases. The most important, one of the most important is to prepare, right? And we've helped kind of shape, high level activities that medical facilities can employ. Kind of expanding on some of these activities. Again, you have to know what you have. So starting with inventory, classify the clinical impacts. and the data impacts, what happens when patients are affected, devices are affected. Creating a list of stakeholders, not only within the medical facility or health delivery organization, but also with the device manufacturers and anyone else. But also, backing up and monitoring, so on and so forth. So check out the playbook. We have some great details in there. So after preparing, right, you have to be able to detect, analyze, and contextualize. And within this phase, you'll have to maintain a number of different initiatives and programs. What I mean by programs are your threat intelligence programs, communication and relationships with information sharing and analysis centers, ISACs. Vulnerability management program. How do you find vulnerabilities? How do you remediate vulnerabilities internally and externally? Are you asking for software bill of materials for devices to understand their software composition, what they're made out of, their essentially their nutritional facts? You get their versioning information and compare them to databases, CVE databases, so you can understand the risk that they're introducing into your network. Other considerations for programs are to maintain a catalog of IOCs, indicators of compromise. And having a SIM and monitoring for security events using that SIM. And incorporating a behavioral profiling mechanism, whether that is something that a vendor provides or something internally. But it is needed. Right? And this is part of detecting, analyzing, and contextualizing according to your organization. Contain, eradicate, and recover. So the activities in this phase of the IR process are dependent on a set of incident response classifications. So these response classifications take into account the clinical considerations associated with the usage of each device. And you'll understand what I'm saying in just a moment, right? So this is the scenarios I was mentioning. So safe to disconnect from the patient and network. So there are no patient safety issues with immediately removing the device from the patient or the network. An example could be a wireless blood pressure cuff. Disconnection from the network possible, but with clinical impact. While the device can operate independently of the network, its disconnection will have clinical impact. A telemetry monitor, which is often used to constantly collect and monitor the vitals of patients in ICUs and other critical units, is an example of this scenario. Shut down or disconnect from the patient with safety implications. So the medical device is providing like clinical necessary functions, and the device is required to be online to perform its function. So an example of this could be a CT machine. Right, these are very real, relatable. Maybe you or someone in your family has interacted with these types of scenarios. And one scenario that is near to me, and I didn't mention it here, is the implantable scenario. What happens when a pacemaker, there's an incident there, and what do you do? And what do clinicians do, and how do they loop in the third parties, the manufacturers, and how do you respond, right? So I found this image quite funny. You cut a virus from your computer, and we had to erase your brain. I hope you've got a backup copy. And in the age of ransomware and the wide, exploitation of ransomware and wearables and implantables, it is not possible to back up, right? In those cases, but you can back up your IT infrastructure and telehealth devices, or maybe not even telehealth devices, but other devices within a hospital network. The next phases are, analyze a post-incident, sharing and updating with stakeholders, and stakeholders could also be the information sharing groups, the ISACs. And then you're looping back around to prepare and incorporating the lessons learned into the playbook, into your processes, and helping, right, with that sharing part, you're helping others learn from what you learn so that they can incorporate into their programs as well. So these ISACs, if you're not familiar, they do have, a sort of confidentiality agreement, which is beneficial, right, in these cases, and obviously probably needed, right? Wrapping up, wanted to provide a table to help illustrate medical device security activities and applicable projects we talked about today. So securely developing medical device software. You can take a look at the top 10, ISVS, embedded AppSec best practices, and zero trust for IoT. Identify medical device vulnerabilities. You can use IoT Goat as a playground and replicate that into a real device. The firmware security testing methodology, the hardware security testing methodology, Byte Sweep as the tool to help you with your firmware analysis, ISVS, right, to figure out which test cases I should be incorporating into my workflow, into my assessment. ISVS, I think I may have skipped over this. It is written in a way that, it is written in verify that. So every control is verify that. Obviously, verification levels, there's 3 of them. So when you're purchasing, deploying, managing, and maintaining connected medical devices, use the IoT Controls Framework, the Secure Medical Device Deployment Standard. You can also use the Medical Device Incident Response Playbook, because there are some good bits in there from the kind of managing and purchasing as well. From the preparing, detecting, containing, and post-medical device security incidents, the medical device IR response playbook, right? Ones that we just spoke about. How to get involved. Hopefully one of these excited you, or you found that there is room where there is a gap perhaps in some of the work that we've performed, or you want to be a fly on the wall and you want to get involved and just listen in to learn. We're available on Slack for Cloud Security Alliance and OWASP. For OWASP, to get access to Slack, go to owasp.org and go to About, and there is a Slack section there. Just input your email, you'll get an invite. You can also reach out to project leaders, whether they're active project leaders or current project leaders like myself. I will help you. I will help you route it to the appropriate person if it's not me. We're pretty easy to get a hold of on socials. You can see my Twitter at the bottom right hand corner, LinkedIn as well. With Cloud Security Alliance, we do have a monthly meeting, again, free to attend and join. And keep in mind, with contributing and getting involved, it's technical and non-technical opportunities. You don't have to be an expert. You don't have to be a super hardware, a super hacker or anything like that. User experience, design, format, reviewing, editing, those are all needed skills. So again, free and open to all who are interested. Here's my contact info if you want to reach me directly. Thank you for your time. Have fun at Biohacking Village and DEF CON if you're there. Appreciate your time. Take care, all.